Advent of Code time. Advent of Code, baby. Where are we at? We did day 1 yesterday. 2 stars. Hell yeah. Day 2. Here's where we're at. Have you really never done AOC before? I don't think so. I'm not sure. It's just never it's never really piqued my interest. Maybe I've done like a little bit of it. I've never done it like end to end. And I've never really like tried that hard of it. Like it surprised me yesterday with the difficulty. Day 2. We're at the gift shop. You get inside. Right, so yesterday what we do, we are an elf and we go to the North Pole. We're doing project management and we're trying to set up all of our decorations in time. Yesterday we got stuck at opening the door to the North Pole secret base. And so yesterday was all about getting inside. We found the secret password and now we're in. Day 2. We get inside and take the elevator to its only other shop, the gift shop. Thank you for visiting the North Pole. Gleefully explains the nearby sign. This is crazy since we had a password to get in. You aren't sure who was even allowed to visit the North Pole, but you know you can access the lobby through here, and from there you can access the rest of the North Pole base. So we're like level 2 password. As you make your way through the surprisingly extensive selection, one of the clerks recognizes you and asks for your help. As it turns out, one of the younger elves is playing on a gift shop computer and managed to add a whole bunch of invalid product IDs, that's pretty funny, to their gift shop database. Surely it'll be no trouble for you to identify the invalid product IDs for them, right? They've checked most of the product ID ranges already. They only have a few ranges that you will need to check. For example, this. So they're saying, I assume that this means that like I'm looking for are these IDs or are they rows of the database? These are IDs. So like I'm looking at product IDs 11 to 22 and I don't know if these are valid or not, probably. They're comma separated. Each range gives its first ID and last ID separated by a dash. Easy peasy. Okay. Since the young elf was just doing silly patterns, you can find the invalid IDs by looking for any ID which is made of only some sequence of digits repeated twice. So 55, 6464, and 123123 are all invalid IDs. Okay. Sure. So it's like repeating in decimal any length. And is it just repeated twice? Repeated twice. Okay, so you only have to check one set, right? It's like if your ID is 10 digits long, you only need to check 55, probably. You know what I mean? Part 2 is going to be repeated at all, surely, right? Surely. None of the numbers have leading zeros. Okay. So 0101 isn't an ID at all. 0101 is a valid ID that you would ignore. Wait, what? Why? Oh, this is valid. Sorry. Ignore as in not remove. Got it. Your job is to find all of the invalid IDs that appear in the given ranges. So is it really that invalid IDs are only things that are repeated? 112299 1010. Yeah, looks like it. And then we add up all of the invalid IDs. Understood. Okay. Kuju, thanks for the raid. What's up, guys? Long time no see. I hope your game is going well. We are doing Advent of Code, finally. You know, I don't know if I've done it before, but we're doing it today. Alright. Let's open our input. Open file. And I guess we'll call this day 2 input. And we technically should close the file, but in reality, it's probably kind of better to ignore it because it's like we're not writing like a fucking library or anything. We know that our application is about to close. So this is, what is it? It's comma separated. So we're like getting a reader with reader buff. Probably reader buff is going to be like a 4K buffer probably. And we're going to, you know, take delimiter exclusive. We're looking for commas. somebody pointed out in the YouTube comments that this API changed in a later version of Zig. So I'm allowed to do this, where I don't, where I don't, this will like consume the comma, but in new Zig, it does not consume the comma. So this is going to be range, and then, can we do like index of in the range of a dash? Something like this, and then we're gonna say like const range start is equal to nope. Range separator is this, where we have like range start is I wonder if working in integers is correct here. It might not be. It might be better to, since we're working in like base 10, it might be better to work on the digits directly. You know what I mean? Because if we're just, because we're almost doing like string comparison. So it might be, it really depends on if it's slower every time to do the increment in what's it called? Base 2, and then convert back to base 10 for comparison. Or if it's faster to just do the increment in base 10. It might be. Right? Equal will be faster. Yeah, so there's, I guess it depends on like, what is like the implementation of repeating numbers? If I'm looking for like 1, 2, 3, 1, 2, 3, I guess this is like, like the getting the divide by stud math pow 10 to like num digits over 2 or something. This gets you like the second half, I think. I think that the truncating division will end up giving you the right thing there. And then to get the right side, I'm actually not sure how to do this. I think maybe you subtract this thing or something. I'm actually not sure how to extract like the bottom 3 digits. I think it's something like that. Right, but like you could see a world where it's, I guess this has to be faster, right? Because like you're everything is in registers instead of having to do like comparisons in memory. Right? So almost surely it's gonna be faster to do it with numbers instead of with memcomp. But I guess also you have to read the numbers from memory in order to convert them here. But if the ranges are big, then you only need to do the like memory inspection or whatever you want to call it on the ends of the range. So almost surely doing this with numbers is better. Oh, also, for the record, people in YouTube comments yesterday were like, just while loop, it's the inputs are slow. That's not the fucking point, guys. That's not the point. The point of Advent of Code, me having never done it before, the point of Advent of Code isn't to like get the right answer. The point is to like use it as a tool to explore problems, right? The problem is the fun, not the answer. So like, if we're talking about like, why don't you just do the compare the strings? It's like, that's, you know, we're thinking about the things that we find fun to think about. You know? But I believe, you're having fun, you're doing it wrong. Yeah. I believe we convert the ranges to numbers and then do the problem in base 2. I think. And then we'll just have to figure out how to like do like the base 10 split later. So this is format parse int. We're expecting to go into probably like looks like they're all positive numbers. Then we're looking at like the range from 0 to range separator index, and we're looking in base 10. Range end is going to be range index +1 onwards. We're assuming no malformed input. They are longs, U64. Boo. But if they're smaller, we can do we go faster maybe sometimes. Maybe. Actually, maybe not in this case. If you SIMD, then yes. But if you don't SIMD, then no. But Zig might auto SIMD for you. So the smaller you get here, the better chance you have of auto vectorization, I think. I think. Int was not enough. Okay. Good to know. We'll see. I'm willing to tank the problem. Okay. So for range start to range end, I guess here these are automatically U sizes in this language, so like fuck it. What are we doing? Okay. So this is what I'm not sure about. Is if I have 1, 2, 3, 1, 2, 3, and I guess 1, 2, 3, 4, 5, 6, I guess is the easier way to do this. If I'm trying to extract the 1, 2, 3, this seems easy to me. It's like just this, right? Int. Hello, does the... how does this language work? Can I not do... Oh, it's you put 2 slashes in this language, right? In Python? Right, that seems obvious to me. But to get the 4, 5, 6, is this the best way? Where you do this times 1,000, take 1, 2, 3, 4, 5, 6, and subtract this? Like, that works, but I don't know if that's, like, fucking stupid. Mod 1000? Oh, fucking course. Am I fucking dumb, fucking stupid, fucking idiot? Of fucking course. Of course. I don't know what... Sorry. Obviously. Fucking obviously. So I guess we need, the only thing here we need to do is like num digits, which I think is 1, 2, 3, 4, 5, 6. You want to do some sort of like math log 10. This tells us, right? This if we do floor here, this gives us 5, which is 1 less, so it's +1, right? What's like log 10 of 0? 0 doesn't exist, so that's not allowed, but 1 is allowed, and then +1 is 1 digit. Yep, okay. Okay! Log 10 int ID +1. Yesterday gave him modulo PSD PTSD, yeah. So if num digits is odd, I assume that we have to check this. I guess arguably there's a chance that this is slower, right? Like the branch of checking this versus just doing the same thing every time. This might be worse. So maybe we just do the same thing every time. So let's do half digits is num digits over, what the fuck did I just do? Num digits over 2. This will do truncating division. Then we just do like something about doing a log 10 followed by a pow 10 feels fucking wrong. I don't know if I'm missing a piece of information, like a way to extract the power here directly. It feels like there's a way, but I don't see it, so for now we'll do this. You know what I mean? This seems stupid. So then we do like ID over divisor. This is top half, right? Bottom half is ID mod divisor. This turns into a div mod, I believe, directly. I bet there's some sort of disgusting floating point trick to this, like fast inverse square root disgusting. Maybe. But yeah, like you parse this thing as a float. I mean, you get to choose the representation, so not sure. If top half, can we do like what are we doing? We're counting Can we split this? Can we just call this like is repeated? Let's just start here. We learned yesterday that it's worth unit testing. Okay, the rule that I want to do this time is that I want to be confident that we have the right answer before we submit it. You know what I mean? Because yesterday we were just kind of like hucking shit at the wall, and I think that's kind of wrong. You know? So can we just try a few numbers here? Stood testing expect equal true to is repeated 1 2 3 1 2 3. We're expecting false on 0 2 3 1 2 3. We're expecting true on 1 1. We're expecting false on 1. We're expecting true on I don't know 9999. False on 9998 or something. Let's just check. Easy, quick check. No leading zeros, yeah, so true. And then we go like if is repeated ID count plus equals 1. This goes here. And we have count here as this. And then I'll assume that if there's some sort of fancy math way to make this branchless zig, we'll figure it out for me. Int and Aryan. We'll just fucking crash. Okay, so he likes this. He does like this. Now, I'm gonna throw a fix me on here. How after log 10 seems stupid feels like there's some way to directly like get there. I just don't know what it is, but we'll see. I mean, I guess like, is this inefficient? What is like a POWI? What in the fuck am I looking at? Holy shit, what is this? Oh, neat. They're like converting it into a base 2 exponent? Wow, mult with overflow. Oh, no, they're doing a while loop here for each level of the exponent, and then they're shifting the exponent right by 1? This is crazy. This is very neat. So the cost here is like it's the base 2, like log 2 of the exponent is the cost here. So the correct answer here is probably to cache the divisor. Right, doing these every iteration is wrong. This is like not expensive, but not free either. So we want to cache, probably the correct answer is to cache to compute once per range and increment as required. Yeah, something like that, but we'll get there. Okay. Do you think this is right? I guess we need our puzzle input. Day 2 input. All right. Open file needs some arguments. And then here, this is gonna be a catch, error, end of stream, break, else, return E. Something like that. 44 is mad, because this guy's like, we're gonna assume valid input again, so we're gonna fucking crashy here. Invalid character. Interesting. What are we doing wrong here? Maybe something like this. What the fuck? Whoa, what the fuck? Oh, is there a new line or something? Is there a new line at the end? No. No new line. Unless saving creates one. What the fuck am I missing here? Oh, yeah, there is this, huh? There is this. Can we just, like, ditch that from the input? How do I remove the new line? Echo it. I guess we can do like a truncate. Like, is there like a head dash C -1 day 2 input? There we go. That just makes our lives easier. Text. That better? Yeah, there we go. There we go. Boom. How confident are we? I feel like relatively confident. I guess we'll see. What? What? Too low. Interesting. Sum, not count. Oh. So true. I can read instructions. Thank you. Awkward. Awkward. Oh, I have to wait 24 seconds. I have to wait 24 seconds. No! No spam allowed. Oh, how dare I? Was that 24 seconds? 7 seconds. 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi, 6 Mississippi, 7 Mississippi, 8 Mississippi? That's the right answer! Let's go! Part 2. This is where we got fucked last time. Clerk quickly discovers that there's still invalid IDs. Right, of fucking course. Maybe the young elf was doing other silly patterns as well. Now an ID is invalid if it is made only of some sequence of digits, repeated at least twice. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 1, 2, 1, 2, and 1, 1, 1, 1 are all invalid. Sure. So it's still repetition, but it's like a little bit more limited now. So I guess the answer here is we find the factors of our number of digits, and then from that we iterate each factor, probably. And how do you find factors? This is like a fucking like grade like 5 problem or something, and I don't remember how to do that. I guess Googling it is cheating. Googling is cheating for now. So the obvious answer is you loop over everything. And is that what I did in elementary school? Is that you just loop over every possible number from me to half the length because because you know you can't have a factor less than 2 and you just fucking mod them all and just check if they're 0? No need to be fancy. Digits are not that long. Boo! Boo! You sound like YouTube comments. Boo! I want to be fancy. That's the whole point. The whole point. There's some people be like, you can be dumb. Dumb approach is fine. Boo! This seems like a question for the fucking idiot, right? I'm down to ask. Like, is there, like, how do you calculate factors of a number? In C, we'll say. Lookup table isn't crazy. That's looking it up. Yeah, I know, but I'm okay cheating for this. I said it's cheating to look it up. Then I thought of unanswer, and then I was like, okay, is there a better answer? He's just doing the stupid fucking thing. Okay, efficient. Here we go. Check up to square root n and output pairs. Wait, what the fuck? For each from value to 1 to square root n, if it divides n, then both n and I are factors? What? Why? Oh! Because any number over something? Hold on. So if my number is like 25, maybe a bad answer. 36. 36. What are my factors of 36? 2 goes 2, 3. So this is like 18. 2, 3, 18, 12. 4 and 9, I think. And then 6 and 6. Right. So because of the fact that 6, like the square root of itself is going to be like, I am the point where I multiply by myself as the factor, then you know that everyone below your square root has a pair on the other side of your square root. So that solves the problem, but you're still kind of fucked in that you still have to loop over all of those numbers. You still have to loop over all the numbers below the square root. Yeah, okay. Sure. Which is probably where I would have ended up anyways. I was just hoping that there was some better answer. But if he's, maybe he's only giving any of the simple answers, but fuck it. Okay. Factor, var, factor, iterator. You need to check, is the number of digits divisible over prime numbers? Oh, did I not read all this? No, I think it's fine. I think that prime factors are different than all factors. But I think that I want all factors, not just the prime ones. I think, right? Like, if this thing is divisible by 4, I want to look for repeats of 4. So prime factors isn't the useful thing. All factors is. Pretty sure. So I guess here we're looking at like I here. And as we iterate this thing, this is like a loop. So here we're probably looking for like limit num probably. And then maybe we cache the square root in here. It is already divisible over 2, no need to check over 4. That's not true, right? Right? If I have an 8-digit number, 1, 1, 2, 3, 4, 1, 2, 3, 4, like, the repeat is 4 long, even though 4 is not, like, a prime factor. You know what I mean? So if I'm checking for the repeats, I need to check for an 8-digit number. I have to check for 1 1 1 1 1 1 1 1 1 2 1 2 1 2 1 2, and then 1 2 3 4 1 2 3 4. These are the 3 things I have to check, and these aren't just prime. So while what true? I guess there's like an end condition to this thing, which is like, so it's like, while I is less than the square root, maybe equal to. Really depends here, not sure. We'll have to come back to this. Less than or equal to? Surely less than or equal to, actually, right? Because like 6 is valid. So yeah, if self num mod self I is equal to 0, return self I. Somewhere we have to like defer, probably here. Something like this, right? Is there anything else here? I think that's kind of it. Let's test this a little bit. So, and then, oh, we also have to return the other one. So maybe this returns a factor pair, or I think that this is easier than us. I think returning the factor pair is easier than us trying to keep track of like each call to next. Give us something else. I guess the other option here is we calculate it again. But I think that keeping these things next to each other will make it more obvious to the compiler that this is a div mod. You know what I mean? I think. But then maybe we only want to do this in here. Maybe the compiler will figure it out. Yeah, maybe this is fine. Why not while self I plus equals 1? Because I didn't know that a syntax existed until like maybe like 3 days ago. I took a glance at some Zig docs and I was like, what the fuck? I didn't know that existed. The compiler isn't doing shit if you're decompiling in debug mode. Yeah, I know, but I'm thinking like for if we get to the point today where we're compiling in release mode and checking performance, like I'm just trying to give it like, you know, the best shot for that. All right. Test factoring. I'm looking for this from another side than you. I try to check how many repeated patterns are in the numbers. I don't care about the length of the single section. There will be X of them. So 2 3 2 3 2 3. I use prime 3 because 3 of 2 3. But why prime? Like 2 3 2 3 2 3 2 3 is also fine. This is 4 repetitions, which is like a valid thing to be checking for, right? So I feel like primes are not involved in here at all, but I could be wrong. So I guess we want to do like factor init of the number like 10, right? Or something. But that would also be 2 repetitions of 2 3 2 3. Oh, I see. Yeah, no, you're right there, huh? You are right. Which makes this, it just like reduces the number of checks that you have to do. Yeah, interesting. Interesting. So what does that mean? I'm still not 100% convinced. So you're saying 2 repetitions or 3 repetitions or 4. Oh, no, yeah, you're right. I think you're right. So you're going from the other side. Instead of what I'm doing, I'm factoring. You still need the factors, probably. It's just which way you tackle the problem after makes sense. Okay, is there like an easy like is prime? Is the validity check for checking something prime just literally looping over all the numbers below it? Surely not. Surely not. Surely not. It is? Because I know I thought that finding primes is fucking hard, but verifying primes is easy. You know what I mean? But yeah, you're saying I only know 2, 3, 5, 7. Yeah, because the digits are limited. That's probably a good point. That is probably a good point. We should write down max digits. I agree. I guess it's here. Var max digits. And then max digits is the maximum of range n and max digit. Or this is the max number, I guess. Not max digits, my bad. Max val. Boom, boom, boom. Max val. Oops. He's mad about something here. Num is num, and squirt is stood mass squirt of num. Alright. He's mad here, sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, yeah. So you are right that you just need 2, 3, 5, and 7. Oh, that makes this really easy then, right? Here, you literally have your, like, you just check the prime. I like this. You have me convinced. So this is going to be, like, 2, 3, 5, 7. Okay, here we go. So we have our primes here. I like this. While I is less than or equal to is less than primes len, we have divisor is primes at self I. And then here instead we go over divisor. Just like this. And then I think we still do want the other side of this thing, because this is telling us what the size of the repetition is, I think. So this is like 2 repetitions of this length. Yeah. So we're expecting so we're expecting 2. Then we're expecting 5. And then we're expecting null. And yeah, that is true. We're expecting like, does this thing do like expect equal? Is this thing like smart? Can I do this? I don't know. True. Void does not support initialization syntax. What the fuck are you talking about? Oh, sure. Sure, if you're gonna be like that. Okay, so that is allowed. Okay, can we try a couple more then? Let's try like 36. So we're expecting what? 2 and 18, 3 and 12, 5, nope. And then 6 is already covered. Oh, wait, do we even need squirt here? No, right? This is just unused. Nice, dude. Nice. I guess technically you could, like, bypass this, but I think it's probably better to just do the same thing every time. Okay. So now here, this is repeated gets a little crazier. So can we do is repeated 2? We still get the num digits here. Do we? I'm looking for the factors of the number of digits, right? If I remember correctly. Yeah, and we're going like while factor it next. Params, I guess. We have like it's no longer half digits, it's like repetition digits or something. And then I guess it's the then I guess we have like divisor here is 10 to the number of repetition digits, and then we're probably getting the mod of like the first, we're looking at like the bottom end digits, and then we probably I think there's a loop in here. So here it's like the num repetitions, potential num repetitions is the first thing. And this is variable, is it? No. For each potential repetition, I think we're doing something like we're dividing something by something, right? We like start with 10 to the repetition digits, and every iteration here, we're trying to do something like if we're checking for 1, 2, 3, if we're checking for like 1, 1, 1, 1, 1, 1, right? We're trying to like extract this digit here, then shift right, then extract it again, then shift right. But by shift right, I mean like divide by 10. You know what I mean? You guys are saying that I want to say repetition. No, I want to say repetition. Reptiton. Yeah, so it's like so that means that we're dividing the input. So like num iterator is num iterator divide equals by divisor, and val is this thing mod divisor, probably, right? And then here we're trying to check if this is the same. So we actually want to go from 1, and we want to start with like 1 iteration of the loop outside, right? So this is like the value we're comparing with. You know what I mean? There's like something like this. And then if val is not equal to comp, if it's not equal, then we like continue this loop, probably. Right? Could we like continue the outermost one? And then if we get to the end, that means that they were all the same, so we return true here. Right? Right? Something like this? I think that's kind of right. It seems like maybe. And then if we get to the end of all this and it's return false, and I think that we missed the one case. Right? We missed in our factors, we need to omit 1 as well. So maybe we check that one last. If self I is equal to primes. I guess when we get here, we're just like return 1. But this isn't just 1, this is like 1 and self-nom, right? This is like a special case here. No 1. I don't think that's true. Is that true? Because if I have 10 digits... Oh, I guess the other... Yeah. The other... One of the other factors will have caught it, right? If it's 1, 1, 1, 1, 1, 1, 1, 1, the prime factor of 2 will catch a repetition here. You're right. You're right. You are correct. All right. Let's try it. Is repeated 2. So let's just try... boom, 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 boom. I guess this is technically true? Ooh. What is the rule if num digits is 1? I guess there probably just aren't any in that range. I think for now we'll just assert that that's that ID is greater than or equal to 10, right? Because like, what the fuck does a single repetition even mean? You know what I mean? Task says that it has to be at least 2. Well, I can't read, so what you gonna fucking do? Okay. So here, let's try to like get into some of the crazier stuff. 1, 2, 1, 2, 1, 2. 1, 1, 1, 1, 1. Can we do 2, 7, 2, 7, 3, 4, 5, or something like this? Then we double check the first one is different, the last one is different, and one of the middle ones is different. 32. Try here, probably. Okay. I mean, this seems to be working. Whether or not it's like correct, who knows? But like at the very least, that it's doing what we expect. Let's just also introduce a like an invalid test just to make sure that we're running the tests. Okay, that's bad. Oh wait, sorry. Yeah, okay. It is, as long as we wrote like a good set of tests, which I don't think we necessarily did, this should work. And then is it still the sum? Adding up all the invalid IDs and this example produces this? Oh, sick. Do we have the example? Let's try that and see if we at least get that right. Dude, we ran it last time without running the example? That's fucking crazy. We're crazy. Day 2 input example.txt. Okay, let's heal this thing up a little bit. And then we have to do the like we do cat day 2 input example Yeah, so it's got a new line on here, so we have to do like a little head trick. Okay, and then wrong thing. We're just in the wrong fucking file. Let's see. Where is it? Input, example healed. All right. So we got 4174379243. They got 65, which is concerning. Watch out for doubles. Oh, are we above or below? 243 265. You are right though. We do. Wait. I think doubles are okay because we return on the first one that it works on. Okay. Can we look at the day 2? Can we just print out this. So we're printing out if it's the number and if it's repeated. Like, what are we doing wrong here? True, false, 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 false. True, 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 true. Okay, this looks like mostly correct so far. Wait, what am I missing? What am I missing here? Did I miss a number on here? Because the idea that it's correct once per range feels right when I'm looking at it. Range should be inclusive on both ends. Oh, really? $265. Ah, it's crazy that we got the right answer for the first thing then. Good catch. Good catch. All right. So, like, maybe. I guess we just fucking run it and see what happens. Ooh. ID is not always greater than or equal to 10. Interesting. Yeah, we have 1 to 20 here. Good thing we wrote that fucking assertion. Good thing we wrote that assertion. So, at least twice. So anything below 10 is just false. If num is less than 10, return false. I guess technically 11. Technically, that's fine. All right. Fucking rip it. Let's fucking go, baby! Whoop, 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 whoop! I got a gold star, dude. We're fucking rich. Hell yeah. That wasn't that bad. This was way easier than yesterday. Maybe because I cheated reading chat for prime numbers, but yeah, because my natural solution would have been a little dumber. Where I would have done all factors. But that's pretty fucking good. That is pretty good. Should we do a run at trying to make it faster in some way? Right? Because we know that there are like flaws in here with how we're calculating this stuff. Yeah, I don't really like specifically this stuff sounds stupid, right? Yeah, let's do some profiling. Let's do some profiling. I think that'd be kind of fun. So the problem here though is that the number list is way too small. So I think what we probably want to do is we probably want to crank up the size of the data compared to string version and benchmark it. Nah, I'm not going to do that. That's too much work. I'm not going to rewrite this with the string version. Okay, yeah, let's do this. Day 2. Can we just generate some input? Let's do that. So we'll say 5530. Let's get crazy for later. Just have a single range from 1 to U32 max. Oh, I like that because it takes all of the parsing overhead out of it. I like that. I like that. Yeah. Input example dot text. Can I save without like a trailing new line? Day 2 hardcore. Like, am I allowed to just go like 1 to like this? I probably have some bullshit in NeoVim that's automatically adding a new line. I guess I don't really know if there's anything that I shouldn't be showing there. There's probably like some like auto command. No, searching for auto doesn't do anything. New line, right, like right. No, I don't really see anything in here. I know you guys can't see it. That's intentional. Hard code in Zig instead of using file. Yeah, that is a better answer, huh? I am down for that, huh? So instead we do this. And fuck the file, fuck the reader. And then I think that we do stud process args. We need to, I'm doing it this way so that the compiler can't get too smart. You know what I mean? You know what I mean? He gets too clever if you give him all the info, you know? And like this, and then this is just one iteration of this now. And we're going from start to end here. And I guess we don't need this max val thing anymore because we know what it is. Okay. So we can go to like 1 to 100. I guess this is try stud format parse int. Like this. Like this. Bing, bang, boom. There we go. Okay. Can we just quickly also say, like, I just want to make sure that this is, like, doing somewhat the right thing right now? You know? Just to make sure, because I could have fucked this up. That looks right. Do we have, like, any 9494? Yeah, this is doing the right thing. This is doing the right thing. Okay. Okay. So, now we can do a little bit of this where we do like, 132. Boom. Okay, good news. That is slow. Good news. Good news. Oh, even that's pretty noticeably slow. Is it supposed to be this slow? Am I fucking stupid? Yeah. We just need to pick like a good number here. 1 misses a little faster. Well, maybe a little more. Add a 0. Okay. I guess maybe not. 37. 30. I guess we want to actually go by like a bunch here. Okay, that's about the right order of magnitude. For like speed vibes. There we go. That feels about right. That feels about right. Cool. Cool. So now we want to see, I guess what we want to do is we want to like copy day 2 here to day 2 baseline. And then we can start getting crazy, you know? Okay, so the obvious thing here is, well, okay, if we profile this, Linux, I think it's kernel packages perf, I think is like the default name for this, but I can't remember. Linux packages, maybe? There's one of these that's like the default for like whatever kernel I happen to have installed right now, is why I'm not using one of these names that they gave us. Okay. So day 2. So we do like perf record. We can get like a rough feel for where this stuff is happening. Right, so we see 99.78% of time is in repeated. Can we expand? And we're seeing like 6% in log 10, which is a little interesting. It looks like, and like maybe like 10% of the time is in this like repetition of power and log I. Where is the rest of the time going? No samples. Probably just appeared in a call chain. Oh, I need to compile with debug symbols. Can I do, how do I enable debug symbols here with the command line? Debug, maybe like symbols or strip is probably the word I'm looking for. F no strip. Probably. Release fast will auto LLVM backend, so I don't think we need to change anything there. No samples. What the fuck? nm-c date. Maybe I need to also like explicitly ask for debug info. Symbols. No. This is what I remember it being. Perf with call graph. Did I not do that? Record -d call graph dwarf. That seems right. This is how I've done it in the past. Can we do it with a debug build? Maybe let's do this. Debug? I must be missing something, but we'll see. GCC uses -g for symbols, yeah. Okay, so here annotating does work, right? So there's something we're turning on release fast is losing something. Right, like clearly we're missing something. Zig release fast debug symbols. It's not helpful. Not helpful. Maybe, I mean, we've surely done this with a build.zig before, so maybe we just do this. Because I'm too stupid to do it the other way. exe is, maybe it's inlining most, but like the annotation should still know where the assembly is for a given set, like a given chunk. You know what I mean? But like maybe, yeah, maybe. Create, add executable. Name is day2. Root module. Create module. Like here, maybe we need to like throw some Dwarf format stuff in here, right? Or something. Root source file is b path day2 zig. Target is our computer. And the optimize mode is release fast. And then we want to do like use LLVM true. We want to like strip. No, root module strip. False. And we want to specify Dwarf format maybe. I don't know. He said over at least Rust you need to enable frame pointers. Oh, interesting. That wouldn't surprise me. I can see why that would be the case. So, good eye. We could try that. Okay. Perf record, and then this is now zig out bin day2. Alright, is that better? Oopsies. No, nothing here still, but let's try explicitly enabling some Dwarf. Record. Report. Still no, huh? It's fucking annoying. Yeah, that's so annoying. So annoying. I want to see the assembly, man. Zig, perf, release, fast. Like strip, strip, dwarf. You know, I just want like, what am I missing? Frame pointer in registry. But do I not have frame pointer here? God, how annoying. What are our options in here? Target, optimize. Oh, we probably want to look at like the door format can be one of these. I did think I did strip false, but maybe putting these in here has like a different effect. Could be. If not, we're just gonna have to give up, right? Error tracing? Maybe. We might just have to give up. Because at the very least, at least we have like functions, right? So we can kind of learn something about this. Right? We can learn that we're using like is repeated. You know, maybe like 70% of the time is going directly towards the actual math, right? Like all of, but we're seeing like 23% in factor iterator, which is interesting. I don't think we can get much faster here. I don't see, oh, but we, like, I want to see the assembly for this as well, right? Like, I want to see which maybe we can see. Like, oh, but we've lost symbols, right? Object, hold on. Like, factor iterator isn't even in here when I search. Which is so annoying. Can we GDB and look at it that way? Can we, like, disassemble? I guess maybe we, like, can we set a breakpoint and disassemble that way? Maybe? Okay, so that's kind of good. Oh, it's all inlined. I see, but we have, like, a little bit of a guess. I see. I see. So here, what are we looking at? It's probably like, I would assume that the data 16 thing that I would assume that this is the list of numbers, primes we're looking for. So I assume that here we're doing some sort of like 2762, that's down here is relevant? No. Oh, 2672. So here. We're seeing, here's our div here. Probably. So this is like, we're iterating over all four one by one. There's no like SIMD magic happening there. But you could maybe get there to be some SIMD magic if you set some limits on the number sizes. Like we know what the max val is, right? So what is this? This is import math log to this 30. So a U32 should be enough, so we can probably gain some speed. Like it'd be interesting to see. Hold on, we need to set our baseline again. Okay, let's just do stupid optimization 1. Where we change all these U sizes to U32s. Some is allowed to be a U size. But this is all U32 now. Okay. And let's just see how different that is. Fuck. Okay. So now we do maybe a little like poop. And I think poop needs it to be a script that doesn't have arguments. So we need to do something like baseline sh call zig out bin baseline with what are our numbers? This one. So we have this. Poop can have args, by the way. Oh. Do they have to be the same for all of them? Let's see. Poop. Zig out bin. Poop. Oh, I see. You do like a zig out bin. Day 2 baseline with 0 to this number, and then we do zig out bin day 2 like this, and then he'll do the right thing probably. Okay, so just by changing U sizes to U32s, let's see if we get anything exciting. Right, so this is already wall time change, not really significant, but we do see some improvement here, which is kind of funny. Like a noticeable improvement for sure. That's funny, but not in wall time. Okay, let's keep going. So the thing that I really feel like we know we can gain like 10% if we can avoid doing the logs and pows in the loop, right? So how do we do that? I guess we want like maybe some sort of like pow cache, right? And here we do like increment. And here we're doing like before we have our index. Keeping the index again here is silly, right? We kind of want to like hold it somewhere, right? Maybe not. Maybe storing it here is like the thing that makes most sense. So it's like if we probably have like our divisor here. I'm missing something. I'm missing something here. I don't know what. It's just like, so because these powers are for each repetition, we actually know that we only have to deal with the factors. Kind of. That's not true. No. Because this is repetitions. So the repetition digits can change per field, but the number of repetitions cannot, right? So it's like, I think it's like we are looking at some number, right? And in here, we're gonna have the divisor cache here, which is gonna be 4 something. You know what I mean? It's like 4 U32s or something, which are related to 2, 3, 5, and 7, right? In some way. I don't know how yet, but it like they must be. Is num digits relevant here? Yes. Right, because this guy is used to initialize the factor iterator. Is this true? Are the divisors shared? Maybe not. Are you solving this with converting the numbers to a string? Yep. Thinking. So we are looking at number 1,000, then 1,001, then 1,002, 1,003. The number of factors are related only to the number of digits. So yes, because this only changes when the number of digits changes. Yes. That is huge for us. Okay. So if num over 10, so I think we do like I don't know, num over 10 what is the like detection case for if our number of digits have increased? I guess it's literally just calling log 2 or log 10, isn't it? I guess we know what the maximum number of digits is going to be though, right? So maybe you can check each of the numbers that you know, increment the number of digits. That's an option. you call log10 on it again, which feels like we're already doing that. So at the very least, calling log10 again every iteration is not like a cost to us because we're already doing that. So here we can at the very least do new num digits is it? So we say like self num plus equals 1. We have new num digits is log10 int on the new number, and we say like if new num digits is not equal to num digits, we update the divisor cache. So here is where we do the factor iterator, I think. Something like this. Oh, this is going to save a fuck ton of time then, right? I think. We'll see. So now we go while factor iterator next. Technically, this could be could limit this by num digits as well, right? Right, you could do for 0 to new num digits, factor it next or else break. This might be better. You know what I mean? Because then you're only going to compute the ones that actually matter. So this is the what is it? It's num reps and num digits. And then we're doing divisor cache I here, I guess, is equal to std math how I u3210 num digits, I guess, but not num digit. We want to call this repetition digits, or else we're gonna get confused. Okay. Then it's like new num digits is new num digits. We are gonna have to check our answer. Do we remember what it was? Shit. We should have written it down. Was it this? No, it was... Oh, no. I think it was this. No, that's still wrong. Probably this one? I don't remember. I think it was this one. But we could check that before. I guess we haven't quite gone so far that we can't double check. So we should just double check now. Okay. Okay. Zig build, zig out bin day 2. No, it looks like this is the right answer. Assuming that we haven't broke anything. And that does look more familiar to me. So we'll just kind of hold this for a second and then we'll come back to it later. Okay. Okay. So, Powcache. I guess we need to like initialize this thing. Somewhere. I'm not sure where. And then I guess this is probably defer here, probably. Probably. If you're looking for task answers, they're on the page themselves or finally. Oh, really? Oh, yeah, it was. Okay, so it was this one. Thank you. Which means we've already broken it somehow. That's funny. But whatever, we'll come back to that. Okay. So num is num. Num digits is... I guess it's like this. This is a POW cache. And then here, before we return, we do like update. And then this has like all of this stuff becomes update. There we go. There we go. I guess you kind of do it like this. New num is this. If these are the same, we return early. And then that kind of gets us here. And then we call self update here, and everybody's happy. Can we do like this to trigger that forced update or something? Okay, and then num reps here is not used, which is a little concerning. So we might not need that anywhere for some reason. No, we must have to keep that. We must have to keep those as well. Reps cache here. That's the trick. Okay. So now, when we come in here, we want to like initialize the POW cache here with start. And then here we do POW cache anchor. We actually aren't using this ID anymore, and I think we just like rip the POW cache in here. I think. Maybe like this. Maybe you do use this because the POW cache has technically incremented the number as the first step in here, which is kind of, or the last step in here. So he's kind of got like, yeah. Okay, that's kind of weird, but we'll come back to it. Okay. So now, how are we doing this stuff? So num digits is in the POW cache, right? Like, I think that this factor iterator is like fucking deadzo. Yeah, which means that the cache here needs to be like cache len, like this, probably, right? Something like this. I don't really have like a good reason why it'd be something else. What's this guy pissed about? Hello? Whatever, we'll come back to it. So now this guy needs to be like self cache len is equal to new num digits? No. Yes. Yeah, it's gotta be. It's gotta be something like that, which means he's already got the factors here, but this might be a loop somewhere, right? So this is like for maybe 0 to POW cache num digits, I think. And then we have like divisor here is POW cache divisor cache I, and potential num repetitions is POW cache reps cache I I think. You know what I mean? Like, that feels kind of right. We do still need this num iterator, which goes here. And then we still need this block here. That's like a maybe. Okay. A small lookup table might go a long way here as well. Yeah, true, huh? Zig build, zig open, day 2. What was our, like, numbers before? Fuck. Where is he getting mad? How I? Oh, here. Missing reps cache. I see. Floating point exception. What the fuck? Am I stupid? Is this wrong? Let's just do this for a second. I'm not 100% sure here, so I'm just going to do this. If 2 digits, we can limit factor next or something. But I don't know how to do this, so. We'll do this for now, because I think that was related to the bug. I guess this just goes in self-cache line here. Or something. Okay, now the question is this, like, still right? So I guess we have our day 2 baseline, who has sum of 7611, and ours is way fucking wrong, right? So we must have fucked something up. We must have. Interesting. Interesting. What am I missing? What am I missing? Okay, I guess we just have to, like, fucking print the POW cache every time or something. Probably with a new line. And I here, probably. Okay. So, num digits 3. It's already fucking wrong. New num digits +1. Okay. Then what the fuck is going on here? Why, like, are we using floats anywhere? Like, hello? Oh, right, we need LLVM on, I guess. Oh, I actually want to be in debug for now, actually, as well. To be honest... Yeah, I guess there is a 0 in there, huh? Which he doesn't like. So this needs to start at 1. Division by 0. So here we have the num digits here looks correct. The divisor cache and the reps cache. So 2 repetitions at 10. That makes sense to me. But obviously something else is wrong here. Divisor 0. So we're doing something wrong here in, we're iterating too far into the thing. Which is confusing because here, like num digits, oh, cache line, my bad. Wrong fucking function, I guess. Okay, cool. So now, are we getting the same thing as the baseline? Baseline from 0 to 9999999. And then are we getting the same thing with the non-baseline? Oops, unreachable. Right, because we want to go 1 to 9999999 in both of these. I guess we shouldn't fucking print every iteration if we're trying to fucking run this thing for real. Okay, good news. Same fucking answer. Same fucking answer. Num digits on 10 should be 2, but you have 1, but 11 has 2. The num increments 1 early. So the logs were kind of right, but it was kind of confusing. Okay, so can we now go back to release fast and kind of compare? We want to run 1 to this number because 0's invalid, and we know that 0's invalid. Okay. Oh, look at that. Look at that. We just doubled our fucking speed, man. We just doubled. We got so fucking fast. We got so fucking fast. What's poop? It's Mr. Kelly's performance profiler. So it just like runs your thing a bunch of time and collects statistics from the CPU. Look at that though. Look how green that is. That's sick. That is fucking sick. It comes out of your mouth. Thank you for that. That's sick. So is there any other low-hanging fruit here that we might want to look for? Yeah, we have this like could limit by num digits. If 2 digits we can limit factor next to something, sure. But like this cache is fine. And then is repeated 2 is no longer doing a bunch of like stupid computations. Like if we do a perf on this thing now, oh my god. Yeah, so now this is kind of interesting, right? We're seeing 10% of our total time is spent in increment to the power cache, but now in terms of like the is repeated thing, which is what is happening, I guess these are both happening every frame. So we're seeing 10% of time here, 90% of time here. So we already can tell, before it was like 30% of time in the stuff that power cache is doing now, so we've like heavily reduced that. And I guess you would maybe look for trying to improve the speed of this. What? Okay. So if we're seeing 90% of time in 90% of time is now in is repeated 2. And the question is there like a better way of implementing this thing? Right? So like what are we doing? We're iterating over the things in the pow cache, which probably you could get clever with here. These probably don't need to be U32s, so you might be able to get like some vectorization by reducing the size of this thing, or because our divisors are always going to be what? Like somewhere below 10 to the power of our max length over 2 or something? Something like that. So U32 is definitely overkill. U16 is probably overkill as well. U8 might work. I guess we know that it's like 32 bits. So the maximum length is like 16. Yeah, easy. Easy. So I think that this guy needs repetition digits. I think we know this can be U8, I think. So these guys can all be U8 everywhere here. And then this is U8 here as well. Div. Oh, but yeah, I think this can be a U8 as well, right? I think that the number of digits is also always can be a U8, no problem. I think. No, he doesn't like that, but I don't know why. Because the number of digits should always be, like, on the order of, like, 20. Can we look at... Go back to debug mode for a second. Can we do... Oopsies. I don't want to be doing this. I want to be doing a... This. Oh, okay. I guess... Oh, yeah, wait, of course. The divisor cache is 10 to the number of repetition digits. So this thing has to be at least a U16. Okay. And then can we look at the baseline as well? I just want to double check that these are the same numbers. Yep, okay. Does that get us any faster? Because, like, I'm just kind of hoping for some sort of, like, lucky vectorization to be happening. You know what I mean? So before we were at, like, 400 something milliseconds, like, about, like, 58% improvement. $444. I don't think that's, like, a noticeable increase from what we had before. It's actually maybe slower, but, like, not within a margin that matters, right? 438 to 444 is, like, who fucking cares? So no obvious wins there. The idea that we can somehow get out of division is kind of interesting. But I think that when you're working in base 10, it's not that simple, right? You might be able to do some sort of, like, shifting, then, like, subtraction or something if you want to get, like, really clever, but I'm not that smart. Yeah, no, this is where most of the time is going. I don't think that we're gonna get, like, much meaningfully faster. Right, when we were looking at this before, we were, like, looking at that log and pow and stuff all at once. We're like, this is happening all the fucking time. It's obviously fucking stupid. Now it's like that one improvement gets us, like, 50% improvement. And was obvious. Now I'm looking at this and I'm like, less clear. So it'd be interesting to see if other people have written some really, like, fast improvements out of there. But I think I'm kind of willing to... This is where I'd be willing to, like, call it, you know? So cool. I had fun. Thanks for watching, guys. If you like what you saw, we stream most days. We run for 12:30 to 4 o'clock Pacific time. It is 3:45 now, so we're between 4 hours ago and now, so you should expect to see us. I think that we'll probably keep doing Advent Code. These are, like, fun little problems and also, like, very accessible to people. But our longer term project is working on a Wayland window manager. So after Advent Code, I think we'll go back to that. We have been working on it in, like, happy hours as well. So if you want to see, the other segment of this stream, it goes up on Patreon, YouTube members, or Twitch VODs. Or if you catch them live, it's free, of course. But archival of those things goes in paid behind paywalls. If you support the stream, it goes for longer. Not in terms of hours per day, but in terms of days per my life. So just keep that in mind. Obviously, no pressure. I think that's it. YouTube, peace, and Twitch is fun someone to raid.